Hello, Fruitport High School chemistry students. So Mr. Kobalak here from the chemistry lab this time. You've watched a couple of lecture slides and notes about how to separate mixtures. And I want to show a couple of them in the lab before we use them. So I got this contraption. I got the camera on a chair on top of some paper towels. And let's hope we get some quality work here. All right. So one of the first ones I'm going to show you is centrifuge. And sometimes students will say things like, I think we did that in middle school. And what we could do for a centrifuge is here's a black marker. And a black marker is often composed of many different other components. And so how can we separate the black ink into the other components? What we'll do is we'll get a piece of filter paper or chromatography paper, and we typically will draw a black line across the bottom of it like this. Okay? And then we have to hook up some contraption where the paper gets suspended in a container, okay? And then I got it tied to the marker itself, and yeah. And then what we're gonna do is add a little bit of water, just enough water, this is important, that the bottom of the paper touches the water, but the water, or whatever solute we're using, does not touch the paper above the line. Now this water is going to, through capillary action, slowly soak up. And as it's soaking up, it will carry the ink with the black marker with it. And if the ink has small particles, they'll get carried very fast. And heavy particles or big particles will get carried small. Just like if you had to walk up the stairs carrying an elementary school kid, it would take you a little bit longer. If you had to walk up the stairs carrying a sumo wrestler, that would take you a lot longer to get up the staircase because we have it. So this one takes a few minutes, so we'll come back and check on it, okay? So we have another separation technique of a filtration. So the big thing with filtration is how do you get this circle of filter paper to fit in a cone? So let me show you the trick. You take this paper, you're going to fold it in half, okay? Nice crease. And then you're going to fold it in half again. And you have this like in quarters now. Now, if you're good at geometry, you might realize between my finger and my thumb, there are 4 flaps of paper. When we open this up, you need to open it up so 3 flaps go one direction and 1 flap goes the other. If you open up with 2 flaps and 2 flaps and try to make a cone, there's actually like a crease. I don't know if you can see the crease through there or not, okay? So you want to open it with 3 flaps and 1 flap. And a little bit of water helps it kind of like hold in place. And now it will stick right into the cup here, into this little funnel. Now we can pour whatever we want into the funnel, and the like solid will get caught by the filter paper, and the liquid will slowly drip through. So you'll get to do that in class too. Okay. Now we'll come back and still check on chromatography. Let me show you a centrifuge. So this is a centrifuge, and this is one of those machines that spins really, really fast. And you can, well, let me show you the top here. If I flip this over, there's 6 little holes that can hold tubes. We got these special test tubes with the little tip at the bottom called a centrifuge tip. And when we put these in, you can never put one in alone. You always have to have it weighted on the other side. So if this one I put in on the right side, I'm going to put a second one on the left side because they're very expensive. And if they're not counterbalanced, I don't know if I can tip this and you can see the tubes are not where they're located. Probably not. But this thing spins. And just like a laundry machine spins fast, and if all like the clothes got on one side and the other side was empty, as it spins, it can like start to rock and shake, and that's not good for the machine's engines and stuff. So the parts. So same thing with the centrifuge. But you'll close the lid, you'll turn it on. It sounds kind of intense, like something big's happening. You'll let it go for a certain number of minutes, and then you'll just turn it back off. And then it doesn't stop spinning right away. You got to give it time for it to slow down and spin. Then you can reach in and you can grab that, okay? So you might see that something's happening to our chromatography paper. And But I want to give it another minute. So let's talk about our last one, my favorite one. Over here, we'll spin to this distillation kit. So this orange box holds it. It costs like $800. So my students don't get to use this too much. And I just put this in the background so you can see it better. But what we have here is a tube where we would put our sample that we want to distill. And then when we heat it up with some kind of heat source, some of the vapors will start to come in this tube. Now, one thing I haven't done yet is turned on the water. So what we do is we actually turn on the water, and we have a hose going from this little pipette or this little tip into here, and then the water actually travels up against gravity and comes out the other hose and goes right into the sink. And there's water flowing through right now, and that will make sure this area always stays nice and cool. So as our sample, like our video, is heated, the vapors will kind of fly around, and some of the vapors will, hit the cold water zone. This is like an inner tube with an outer tube, so there's nothing mixing there. And then the gravity will take the liquid and start dripping, and you'll have some kind of container that will catch drip, drip, drip at a time. And then sometimes you got to do like an Indiana Jones thing, and you got to have a second one ready, and you're like, okay, and stop, and then collect a new sample, and then we can test them, okay? And we have a thermometer that kind of tracks the temperature here, but this is a little bit of the setup of a distillation kit. You won't get to work with one, but I wanted you to see what one looks like, okay? If you take AP chemistry, you'll get to see one. All right. And really quickly, I can show you here, we have our black ink was taken and separated into some different colors. If we give it more time, it would spread out even more and be really clear. They would actually use this technique if, someone kidnapped somebody and left a ransom note in a black marker, and then they found a couple suspects, and they're all carrying black markers. Well, which black marker was used to write the ransom note? They could use the chromatography technique to match it up, because not every company makes the same recipe for black marker. So anyways, a couple ways to separate mixtures. We're going to do a mini lab with this in class Monday or Tuesday. All right, cheers, everybody.